for part 3, show that there is no point on the curve y equals g of x where the gradient is -1. So we've already found the gradient function in 9 part 1. That's what I've got here. So let's steal that. And let's think about why that's never going to equal -1. What we can do is make it equal -1 and see what happens. So if I bring this up, there like that, let's try and solve this. So we're going to have x squared, x to the 4 plus 10x squared plus 25. So that's 75 minus 15x squared equals minus x to the 4 minus 10x squared minus 25. So if I move everything over to the left now, that's x to the 4. If I add 10x squared onto here, that's going to become minus 5x squareds. And if I add 25 onto here, that's going to become positive 100. So if we try to solve this, does it have any solutions? Well, it's set up, it's like a quadratic. So if you think back to your C1 or C2, the discriminant determines how many solutions this will have. So if y squared take 5y plus 100 equals 0 has no solutions, then this won't either. So if we find the discriminant of this and it's negative, that means there's no solutions. So let's find the discriminant. So b squared is minus 5 squared. Minus 4 times 1 times 100 is 25, take away 400, which is minus 375. So that's negative. Discriminant is negative, therefore no solutions, which tells us the gradient is never -1. So quite unusual because we've had to use the discriminant. You could have tried to solve it using the formula because it wouldn't factorise, and you'd end up in your b squared minus 4a squared. When you come to try and square root that would be negative. That's the whole point of this discriminant. That bit under the root is the bit that decides whether we're going to have solutions. Because if we can't square root it because it's negative, there'll be no solutions.